Hello, am I audible? Hello, am I audible?
Yes, Himanshu.
Okay, so hello everyone. So in the last class, we actually looked some problems related to equilibrium, and we will solve one or two more problems, and then we will move to trusses. So there we will be solving the problems by method of joints. But before moving to trusses, let's solve few couple of problems more. So last time we discussed about few problems of equilibrium, and we discussed that in any question of the equilibrium, first we actually need to decide the coordinate system. And in the problems we solved, uh, in almost all of the problem we used the Cartesian coordinate system, mostly in the 2D plane. Then we need to draw the free body diagram. That is very crucial before solving the equilibrium problems. And in the free body diagram, we actually need to consider the type of joint. So last time we actually considered three types of joint: roller joint, pin joint, and the fixed support. And we saw that in all three joints, the reaction forces will be different. So for example, in the pin joint, we had two component of reaction force, which is Rx and Ry. But if we have a roller joint, then we have only one component of reaction force, which is exerting here, because and this reaction force is based on if the motion is constant or not. If the motion is constant in any direction, then there will be a reaction force. Otherwise, obviously, there will be no reaction force. And if we have a fixed support, then there will be a reaction force and reaction movement also. So there will be a movement and both component of reaction force which will be there. So all these things we need to actually consider in the free body diagram. Along with the reaction force, we also need to indicate all kinds of forces, body force or any kind of surface force or external force, which actually exerted on the system. So after that, we can actually use the equilibrium equations. So when written in the scalar form, we saw that we have to solve uh, at most three equations. So these are the three equations of equilibrium where the summation of forces and summation of movement is zero. So now we will be using the equilibrium concept for this problem. So here, first we need to draw the free body diagram, and then we need to find the reaction at A and B in this problem. So we know the approach. We just solving this problem for more practice. So as usual, we need to make a free body diagram, and we will be using the Cartesian coordinate. So this is my A, and this is B. So you can see actually from the figure that at B you have a roller joint and at A you have a pin joint. So in the pin joint, uh, translation motions are constant, and even though you can rotate this bar, but there will be no translation motion, and therefore there will be no reaction movement, but there will be a reaction forces in both the direction. Let's say it's AX and AY. This is my X and this is my Y. And at B you have a roller joint, and therefore you have only one component of reaction force, because it can move in X direction and it can also rotate. So there will be no reaction force in the Y direction. It will be zero. And then you have to show all the forces. So the and movement as well. So there will be a movement here, which is 2 kilonewton meter. and a force F, which is 4 kilonewton given in the question, and then we have given the dimension that will be useful while calculating the movement. So as usual, we will be solving using this equation. So if we consider first equation where the summation of movement in the x direction will be, sorry, summation of force in the x direction is 0, then we can see there are only two forces in the x direction. One is Ax and this 4 kilonewton. So Ax minus 4 equals 0, which will give us Ax is equals to 4 kilonewton. Then so let it be By. This should be Bx. Then if we use the second equation where the summation of force in the y direction is 0, then we will be having unknown Ay with an unknown By. So this will looks like Ay plus By equals to 0. So both are unknown, so we don't have any idea about this how to solve. So we require another equation where the summation of movement will be 0 at about some given point. So if we take the movement at A, then I can actually calculate about By, because the summation, I mean the movement due to this force will be 0. So we have to figure out which force is producing the movement about point A. So you can see the perpendicular distance for By is this, which is zero point 0.3 plus zero point 0.3 plus zero point 0.4. That means around 1 meter. And then this, for this force, the perpendicular distance is this from point A, which is 0 0.2 meter. And if I consider clockwise movement as positive and anti-clockwise movement as negative, and then we can decide the direction of movement. So you can see the direction of force is toward left side, and at around point A this will rotate like this, that is in the clockwise direction. So due to this force there will be a positive movement around point A. Similarly, the By is towards top direction, plus y direction, and it will rotate like this about point A, and you can see it's a counterclockwise movement. So from this we will get 4 kilonewton multiplied by its perpendicular distance, which is zero point 0.2. It's a positive movement. Then minus By multiplied by 1. And then we have to consider this movement, which is in the clockwise direction. This is a couple. So it will be direct, plus 2 equals 0. So here we will get By equals to 2.8 kilonewton. And from this equation, we know that Ay equals to minus By, which means if we got By, we can also have Ay. So Ay will be minus 2.8 Newton. So these are the unknown that we require to find. And we did nothing different here in this question. We just follow the same procedure that we have been doing since last class. So we have used these three equations summation of forces and summation of movements. First we make the free body diagram, then we use summation of force equation, and we got one equation, and we found that in this equation two quantities are unknown, so we required to use third equation, and by using equation 2, which is this, and equation 3, which is this, we can able to find the unknown reaction forces. So any doubt? So if not, then we can move to our next topic, trusses. So there are still few problems here in this sheet. So it's the same problem. You have to use the same procedure that we have been using since last class. So first procedure is to define the coordinate system, and in our problems we usually deal with the Cartesian one. Then make the free body diagram, include all the reaction forces, body forces, and all type of external forces. Figure out about the joint. It is important to consider joints. So here you can see you have a pin joint at A, and at B you have a roller joint. So at pin joint you will have two component of reaction forces, and at roller joint you will have only one component of reaction forces. So this we have discussed in detail in the last class. Whereas if you have a fixed support, then you will have two reaction forces, Rx and Ry, and you will have one reaction movement as well. So this we discussed in last class. We also solved problems on all of this concept. Now you have to include all kinds of forces. So reaction force or body forces. So once you figure out the reaction forces for these three kinds of different joint, you just show in the free body diagram like we have shown here. Then you have to use the equilibrium equation on this free body diagram. So now we move to the next topic, which is truss. So in truss we will going to start with the method of joint. So it's the same in the method of joint we will be using the same concept of equilibrium. So it is just an extension what we are doing since last class. So method of joint is a very powerful method, because what happens, you have given random truss, you just need to consider one joint, and in that one joint you need to use the equilibrium equation. So basically method of joint help you to describe the forces of or the concurrent forces on the joint. So for example, you have this joint and there is a truss, let's say. So this is the given truss. You just consider any of the joint. Suppose you consider this joint. You just zoom it out. So you can see these are the concurrent forces because these are meeting at one point. So here in this joint you need to first, then you need to apply the rule of equilibrium. So what we learn in the equilibrium, first you decide the Cartesian coordinate system. It could be any coordinate system. Then make a free body diagram, and then use the equation of equilibrium. So you need to apply exact thing on each joint here. So here first you need to decide the coordinate system. So most of the time it will be just a Cartesian coordinate system. Once you decide it, then make a free body diagram, which is very easy in case of a trusses because we are considering only one joint. So for a one joint it is very easy to do that. Then you have to use the equilibrium equation. So most of the time you need to use only the summation of force equation. So this is the procedure for the method of joint. Now when you're deciding the coordinate system, you can decide different coordinate system for different joint also. So for example, in most of the case, let's say you have a joint like this. This is your joint. So here you can decide the Cartesian coordinate system as x and y here. But sometimes you will get a truss like this. So this is the joint. These are the members here. So in this case, you can decide the coordinate system like this. It is just to simplify the problem. So now this will be your coordinate system. So this will be your horizontal direction and this will be your vertical direction. So this is just to simplify the problem. For example, if you use this coordinate system here to evaluate the forces at this joint, then what happens, you need to take the component of these forces, this and this forces. You need to consider the x and y component of these forces. So it will become more involved in mathematics. So just to simplify the problem, you can use or you can adapt this coordinate system, and when you do that, you don't need to take any component because it's in the x direction, and the forces in this member are in the y direction, so you don't need to consider any component. So mathematically it will simplify your problem, so that we can do in every joint. Remaining procedure will be similar, and it is an extension from the equilibrium problems. So we can, and one more extra thing that you need to consider while solving the trusses problem is to see whether the truss is determinate or indeterminate. So for example, let's say you have a members here, and sometimes what happens, if this members, all of this truss is in equilibrium, you will have some extra members which are fitted here, and you can actually check whether the members you have, whether it contain extra members or not. So if it contains any extra members which is not participating in distributing the force, then it is an indeterminate truss. Or whether it lacks a member such that it requires an additional member but it lacks a member in the body. So for that you can actually check by using this equation. So here M is the member and J is the joint and R is the reaction forces. So if the condition satisfy this, then only you can use the equilibrium equation at every joint. So that this is a condition you uh, need to check before solving by method of joints. So this is the extra condition that will be helpful in the truss. So along with this condition, all other condition will follows for the equilibrium concept. So let's consider one example. So let's say this is the truss we have given, and we need to determine the forces by considering all the joints. So first, as usual, we will be we will be using the determinant, we will be using the equation to see if this truss is determinate or indeterminate. For that, we have to use this equation. So M is the member, R is the reaction forces, and J is the joint. So you can see there are 4 joint in the trusses, so J will be 4. And there are 3 reaction forces. You can see there is one roller joint and one pin joint. For the pin joint there will be 2 reaction forces, and for the roller joint there will be 1 reaction forces, so it will be 3. And members you can count, there are 1, 2, 3, 4 and 5 members. So this equation should be satisfied. So M plus R is actually 5 plus 3 and 2J. J is 4. So you can see this will give you 8 and this will also give you 8. So this is the consistent truss. So here since you satisfy this equation, now you can use the method of joint. So once you start with the method of joint, it is just an equilibrium concept at each joint of the truss. So we will be using equilibrium concept here. So first make use of coordinates, then draw free body diagram, and then use the equilibrium equations. Which is F. Force in the horizontal direction is 0, force in vertical direction is 0, and summation of movement is 0. So here the summation of forces in x and y direction. So these are my equilibrium equations. So that have to be used and at each joint. So let's consider joint C first from the above problem. So first we consider joint C. So now we have to first decide the coordinate system. So my coordinate system will be as usual. This is my x and this is my y. So this is done. Now I have to make the free body diagram at joint C. So this is my joint C. So there is an external force of 400 Newton, and then there will be a forces in the members CD and CB. So this is CD, and let's say this is CBC, and let me make the coordinate system here. It's x minus x, y minus y, and this angle is given as 45. So once you make the free body diagram at a joint C, then you can use this equation, equilibrium equation. So let's first use summation of force in the x direction equals to 0. So there will be a force CD minus component of force in BC member. So it will be BC cos 45 equals to 0. And we can see that both are the unknown force. We don't know the force in CD as well as BC. So then we will be using force in the summation of force in the y direction and equating to 0. So here we can ignore the force in CD because it's in horizontal direction, x direction, so we don't need to take care of it. So we can easily find the force in the member BC here. So it will be 400 minus BC sine 45, and that's equation 2. So it will be BC sine 45 equals 400. So BC equals 400 divided by sine 45. So this will give me force in member BC will be 565.77 Newton. So this is the force in the member BC. So now we need to actually tell whether this force in the member BC is it a tensile force or the compressive force. So for that there is one rule to describe the nature of force. For example, let's say this is your joint, and if the force is away from the joint, then it will refer to as a tensile nature, which usually denoted by T. And if the force is if the force is toward the joint, then it will be a compressive force.
Himanshu, I had a question.
Yeah.
Would it be okay if I ask?
Uh, Hello. Yeah. Yeah.
Yeah, so the BC should be BC cos 45. No? It should be in this case, since it is 45 degree, it's still okay because sine and cos 45 are same.
Yeah.
But it should have been cos 45. At any other angle, it would
Cos
cos.
cos 45. You mean in the this equation here?
Yeah, because that's the angle.
No.
Um,
So you can see here. So this is. Let me make the diagram here. So this is our joint, and this is BC, and you can make a triangle here. So this is our
yeah,
45.
yeah, got it. Sorry,
Yeah.
I
Yeah.
just the direction I took it on. So
Yeah.
no, no,
So you
you're
can
correct.
have a right triangle here. Yeah.
Yeah, got it. Thank you.
Right. So if the force is away from the joint, the direction is away from the joint, then that will be referred to a tensile force. And if it is towards the joint, then it will be referred to as a compressive force. So you can see for the BC case, it is the member force in the member BC, it is going towards the joint. So this will be compressive in nature. So that is very useful in the process problem to describe, because in many question they ask you to, they ask you to describe the nature of the forces. So this is a good way to describe the force at each member, right? So now we got the force in the member BC, we can easily find the force in the member CD, and if it is positive, then we know that the force in the member CD is also compressive because it is in the direction of joint. If it came out negative, then we have to reverse the sign of forces. So let me solve here. So basically, I now we know what is the force. Sorry. Now we know what is the force in the BC. It is 565.7. We will be using equation 1 to get the force in the member CD. So it will be CD minus 565.7 cos 45 equals 0. So this will be CD. Come out to be a 400 Newton. It's a positive. It's so the sign is positive, which means we don't need to change the sign. We assume the correct sign, and it is towards the joint, so it is also compressive nature. Okay, so we got the force in the member BC and CD when we consider the joint C. Now we can consider the joint D, let's say, and we will follow the same step. So first, let me make a free body diagram. So this is my joint D. This is CD. Let's say this is my AD. This is DB, right? Okay. It has an angle here 30, and this has the angle of 15 degree. So now here we can use the coordinate system which is aligned along the DB. So we can simplify our calculations. So if I choose the coordinate system like this is my X, this is my Y. So this will be minus Y, this will be minus X. So I'm choosing along DB. So it is convenient in such joint because as I described in earlier, if you choose this kind of coordinate, like some tilted coordinate along this joint, so you don't need to consider the component of force, or even if you need to consider, the mathematics will or the calculation will be simplified. But instead, if you consider this coordinate system here, you will get the correct answer, but it will be more involved calculations. You have to consider the component of each member. So here this is the same situation. So you can see there is a member here, uh, which is almost perpendicular to this long member. Here we have similar situation, like there is a third member here in between CD and AD. So we actually want to align the coordinate along the third member. So when we do that, let's first consider the force along y direction, in this direction. When we do that, we don't need to consider the force d to db because it's entirely in the x direction. So we don't need to consider the component of db, right? If we would have choose this usual coordinate system, then we have to consider the component of dB also. But we choose the coordinate system along the dB, and the dB is in the x direction. So if we want to solve, if we are using or if we are doing the summation of force in the y direction, then we don't need to consider the force dB because it is entirely in the x direction. So here we need to consider the component of force of AD and CD, right? Because they are not normal or along the y and x axis here. So this will be now. So you can see AD is in the negative y direction. It is going downward. So this will be minus FAD. So you can make a triangle here. Sorry. You can make this triangle here, and you can actually see the component of force along the y direction for AD. So it will be sine 15, right? So if you make a triangle here, this is the 90-degree angle, and sine will give you this. Sine is the ratio of this part of the triangle and this part of the triangle, right? So this is the AD, and this part of the triangle you want to know, which is FAD sine 15. So this is one of the thing. Then you have 400. So 400 is CD. So we have calculated the value of CD, which is 400 Newton. And again you can decide the components. So you just, so this is your triangle. So this is 90 angle. So this will be the triangle now, right? So you have this side of the triangle you already know, which is CD, and you need to know this side of the triangle, which is the component of CD along the y direction, right? So it's again sine. So it's sine 30 equals to 0. So from this equation you will get force along AD. So it will be minus AD equals 400 sine 30 divided by sine 15. So this will come out to be AD equals minus 772.8 Newton. Yeah. So this is a minus sign, so we have to reverse the sign for AD. So earlier we assumed the sign of AD here, which is going in the downward direction, but actually it should be in this direction. That is towards the joint. So earlier we assumed the force away from the joint, but it is now towards the joint because we have got minus 772.8. So which means it is towards the joint. It tells us it's a compressive force, right? So we now got the force in the member AD as well. So now we need to calculate the force in the member DB. So let me write here. So for DB, let's consider another equilibrium equation and let's see what we get after we solve this equation. So let's assume the component of force in x direction equals to 0. Then now we need to consider the force dB here. So now because it's along the x direction, so it will be dB. And then we have to consider the component of CD and ED. And we already know CD, and now we also got AD force, magnitude of AD we know. So we can easily found dB because it is the only unknown force in the free body diagram. So following the similar rule here, we already made the triangles for each forces and found out the y component. So we can from the use of same triangle we can actually calculate the x component of CD and AD as well. So when you look this triangle, this triangle and this triangle, you will find, sorry, AD multiplied by cos 15 minus 400 because it's going in the minus x direction, which is cos 30 equals 0. So dB plus minus 772.8 cos 15 minus 400 cos 30 equals 0. So here you will get around 1.09 kilonewton. and the direction of dB here we assumed away from the joint here. This is the assumed direction for dB. This is away from the joint, so this is the tensile force. So we now find the force at dB also. Now the only unknown force is in the member AB. So for that you can take any joint. You can take joint A or joint B. So let's take joint A and repeat the exercise. Right? So from the previous calculations in the other joint, you can estimate the direction of force. So let me make a force direction of force here. So you can see when we consider joint D, the direction of AD is towards the joint here. It's towards the joint here. So when we consider A, it will be like here, like this. When you consider the other end of the member, it will be equal and opposite force, right? And similarly, you can draw the forces in the other direction. So in the dB, it was away from the joint like this when we consider joint D, and when we consider joint B, it will be in the direction of this, equal and opposite. So when you consider joint B, you have to draw away from the joint. So the force in dB will be away from the joint, even if you consider joint B. So since we consider joint A, the uh, direction of force in member AD will be towards the joint. So that definition where we are assigning the direction, like towards the joint is compressive and away from the joint is tensile, that definition helps to assign the direction when we consider another joint. So first you have to assume the direction. When you don't know the forces in the members, you need to assume the direction. And once you get the magnitude of the value of the force, it will tell you whether your assumed direction is correct or not. So for example, when we found dB, force dB, we got minus 772, which says that our assumed direction was wrong. So we reversed the direction and we found it is away from the joint, towards the joint, which was the compressive in nature. So once we got the magnitude and the direction, then the definition helps you to assign the direction when you consider another joint. So the first we get to know that it's a compressive force. So it is towards the D joint when we consider joint D, but now we are considering joint A. So it will follow the same definition towards the joint, even when we consider joint A. So this will be in this direction towards the joints, and this is AD. And since we don't have any idea about this member, we don't know the force, so we assumed the direction here. And let's say I assumed direction like this towards the joint. And if it is incorrect, then the equation will tell us. If it is come out to be a negative, then it will be away from the joint. So this is our assumed direction of force. So it is AB. And then there is a reaction force. So it's a roller joint. So there will be only one reaction in the y direction. This is my AY. And make a, so here we are making regular Cartesian coordinate minus x, x, y, minus y. Right, because this is almost not a complicated distribution of force around the joint, so we can use the simple coordinate. Unlike previous case, we have where we have a tilted coordinate along dB, force dB. So now we repeat the exercise. Summation of force in the x direction is 0. So we will have AB and component of AD. You can check in the free body diagram. So it will be minus AB and plus AD cos 45 equals to 0. We know AD and it is minus 772.8. So here I'm not considering minus because I already changed the direction previously because it come out to be minus. So we discussed that it is towards the joint, right? So I assumed our direction was wrong, so I change it to towards the joint. So it's a towards the joint case here also at point at joint A also. So I already consider this reverse direction. So that's why I'm not considering minus sign here because I already considered already reversed the direction in free body diagram. If I use the older free body diagram where I have not reversed the direction, then you can use this minus sign because the ultimate goal of this minus and plus sign is just to guide you about the direction, and that we already corrected. So it's a plus 772.7 cos 45. It's 8 actually. So AB will be 546.45 Newton. And this AB, since it is positive, we don't need to reverse the direction of force. So our assumed direction here is correct, which means it's towards the joint. So this is the compressive force, right? So now we found the force in all members. So it is compressive here. It is compressive here. I mean, all forces are compressive except the force in dB. So it's tensile here. Remaining forces were compressive. So by considering three joints C, D and A, we actually found the forces in all the members. So even though it is a little time taking, but you can see since we already learned about equilibrium, how to use the concept of equilibrium, it is easy to understand. So any doubt in this problem?
Is there any way to intuitively understand if the member is in compression or tension without solving the problem, or we have to solve the numerical and only then we'll understand?
Yeah, you have to solve the problem because you are taking each joint separately and there are too many joints, too many members. So it is better to solve problem one by one because if you consider a joint, there are too many forces this joint is experiencing from too many because there are multiple members connected to joint, and therefore it is very difficult to uh, visualize the nature of forces this joint have. So the nature of forces I mean the direction of forces at each member, how much the joint is experiencing the force, what is the direction of force, all these things it's very difficult to visualize because there are too many members attached to a joint. So it is always I mean better to solve the problem mathematically and then the mathematics guide you about the direction of the force here.
Yeah, got it. Thank you very much.
But in some cases where you need to find the zero force member and so on, that you can actually by visualization itself you can actually see the zero force member. Like for example, let's say this is the joint, this is one member A, this is member CB, this is member AC, and then let's say this is AD. So by visualization, you can actually see that the force in member CD will be zero. And when you use the equilibrium conditions or equilibrium forces to solve this equation at joint C, you will get the same thing. So whenever you have this kind of settings, where you have a two member in the horizontal direction and one member in the vertical direction connected in between, like that. So the member force in the vertical member will be zero. So this you can actually visualize, and without even using the mathematics you can actually set the force in that vertical members as zero forces. So this will be the zero force member.
Got it. So it's purely aesthetic, right? So it has no structural use in that case, that
Yes,
particular member.
yeah, yeah. So it will not share any force, but it will not let the truss buckle. So, for example, since this AB and CB will carry a force, so if you don't follow the assumption that the bodies are rigid, so I mean, as of now, we are following the assumption that all the members are rigid. So we are neglecting the deflection or deformation in the members. But let's say in the practical life, this assumption is not going so well, and there will be some deflection or deformation due to the force AC and CB. Then this member will restrict the deformation to happen. So this is the use of this zero force member. So even it is carrying no force, it will also avoid the deformation which is occurring by force AC and CB.
Okay, got it. So it has a functional use, just
Yeah,
not this
yeah,
case, the
yeah,
accessories.
yeah.
Got it.
So now let's solve this problem. Here we need to determine the axial forces, and we need to indicate if they are tensile or compressive force. So basically, I mean, when you use the method of joint, the question will be similar. You need to find the forces in each of the member and determine the nature of forces in each of the member.
So if this question gets asked in the exam, right, it'll take roughly 30 to 40 minutes just to if it's a if the members are more. So there is no other shortcut, right? We have to do the way it is, every joint and everything.
No,
So
there is a, I mean, shortcut. So next week we will be using the method of section to solve the problem. So usually method of section used to solve a very complicated looking truss problem like we have here. So like here we have too many truss. Like here you can see there are too many members in the truss. So
got it.
this type of problem, we can use the method of section. So there, what we do, we actually uh, cut this truss. Let's say I cut this truss like in this manner, and now we have to solve the forces in this member of truss only. And then we will be using moment and force equilibrium method to calculate the forces in unknown members. So there we will not solving in each of the members. So in the question it will be given to solve the force in some specific members like this or this or
Got it.
this, like
So
that.
depends on the question purely. Like
Ah,
if they ask only find the force in this particular member, in that case this makes sense. But
yeah,
if they ask in all the members, then we have to do the way you did right now. So that is going to be time consuming in an exam.
yeah, yeah. I mean, in the exam, if it is a short question, then mostly they will not ask. I
Not
mean,
ask. Oh,
yeah,
then
such.
it's fine. Then it's fine.
Yeah.
Thank you.
Yeah. So okay, let's solve this problem. So as usual, we need to check if we can apply the method of joint. So we need to check if the truss given here it's determinate or not. So for that we will be checking by the same equation. So we have a member, it's a three member, one, two, and three. Then we need to count the number of reaction force. So we have a pin joint here and the roller joint here. So in the pin joint we will have two component of reaction forces, Bx and By, and in the roller joint we will be having only one component, Cy. So we have three reaction forces, and then there are three joint, A, B, and C. So you can see LHS and RHS will be equal to will equal to each other. So now it satisfies this equation. Then we can proceed by method of joint, solving by method of joint, which is basically an extension of equilibrium method. So basically we are using the equilibrium concept at each of the joint. So if I consider joint A first, this, there is a force 800 at an angle 20, and then there will be a force AB and AC. Let me assume the direction of force AB away from the joint, and there is a force AC, which I am assuming again away from the joint. So we have given the sides of, the length of each member, zero point 0.7, zero point 0.7 and zero point 0.4. So basically this is my 0 0.4 meter and this is my 0.7 meter. So I can use the law of triangle, ratio of triangle. So it's 0.4, zero point 0.7, or I can use 4 and 7 because it's a ratio only. So by Pythagoras theorem, this side will be root 65, right? So in the first lecture we uh, saw the example, we solved one question where we solve the component of force by use of an angle theta. Then we solve the component of force by using this uh, triangle ratio. And in the third part, we actually calculate the angle theta first and then solve the problem. So here I am considering the ratio because we already given the length here. So here it is 4, here it is 7, and by Pythagoras you will find this length as root 65. So here our objective is to use the ratio of this length. So for cos we will be using 7 by root 65, right? Because when we use cos theta, it will be the base divided by the longest length. Similarly for sine, it will be 4 divided by 65. So this is my cos and this is my sine. So for AB, and let me make a coordinate here which is x, and this is my y. So if I use the summation of force in the x direction, then it will be, you can see it is actually going towards the left side. The direction of force, if I compare with the coordinate system, it is actually going towards the left side. So it will be minus 800 sine 20. Then AB will be, again it is in the minus x direction, so it will be AB 7 by root 65 plus AC in the positive x direction, so it will be 7 by root 65 AC equals 0. So there are two unknown, AB and AC. So we need one more equation, which is summation of force in y direction equals 0. So here you can see it's going in minus y direction. So it is minus 800 cos 20, then minus sine component, which is 4 by 65, 4 by root 65. This is my sine component AB. Sine component means I actually need this component and I already know this one. So this will be given by sine, right? So this is 4 by 65 minus 4 by 65 AC, because both are going in downward direction, which is minus y direction. So both are minus, equals to 0. And this is again equation 2. So when we solve this two equation, we can find the force in member AB and AC. So the second equation will be minus 751.75 minus 0.496 AB minus 0.496 AC equals 0. So I can write this equation in terms of AC or AB. It's your choice. So let me write this equation in terms of AC. So it will be minus 0.496 AC equals to 751.75 plus 0.496 AB. So I can write AC as 751.75, so minus 0.496 AB divided by 0.496. So now I write this equation in terms of AC. You can also write in terms of AB, it's actually a choice. So now I substitute this expression in equation 1. So in AC, I will substitute this expression. So the whole equation can be written down in terms of AB. So we can solve AB then. So 800 sine 20. So let me directly solve this. So it is 273.616. This is actually 800 sine 20. Then AB 7 by 65, root 65. 0.8 0.868 AB plus 0.868 multiplied by AC, and instead of AC I am using this expression of AC. So this is minus 751.75 minus 0.496 AB divided by 496, and this is equal to 0. So now we just need to simplify this equation. It's all about solving. It's just a mathematically involved equation. So this will be minus 273.616 minus 0.868 AB, and I can divide this and this. So it will be plus 1.75 minus 751.75 minus 0.496 AB equals to 0. This will be 0.868 AB equals 0. So this and this will be minus 1589.178, and we can club this with this. It will be 1.736 AB equals 0. So this will be minus 915.42 Newton. So we got AB in minus, so our assumed direction is wrong. So it should be towards the joint, which is compressive force. So this is compressive force. So now you found AB, you can use this equation or any equation 1, 2 or even this one to find AC. So when I use this equation, I will have AC equals minus 751.75 minus 0.496 AB, which is minus 915.42 divided by 0.496. Then I will get so this I will get as minus 600 Newton AC. So again this come as a negative 600. Negative means my direction of AC is also incorrect. It should be away, towards the joint, not this. So this is also compressive force. So we got the force in this member and in this member. And we can now find the force in this member. So you can see, if you consider joint B, then you have to deal with Bx and By and force in this member. But if you consider joint C, you need to deal with only Cy. So instead of dealing with Bx and By, which are unknown, both are unknown, I can deal with a single unknown force, which is Cy. Single unknown reaction force, which is Cy, and then with this member. So if I take joint C, then there will be a force Cy, assumed direction force Cb, and then there will be a force. So this force in the member AB and AC, it's towards the joint. We got towards the joint, so it will be in this direction. Sorry, in this direction. This is my AC, which is towards the joint. So I need to consider only three force. If I select joint C, if I select joint B, then I have By, Bx the assumed force, which is BC, and the the force we calculated, AB. So here you have to deal with four forces. If you consider joint B, if you consider joint C, you have to deal with only three forces. So let's consider joint C because it will make the calculation simpler. So this you need to inspect because you have both option. Then you need to inspect while solving the problem that which joint is suitable for you. So here we found that if we choose joint B, it will be mathematically more involved. So there we need to find three forces, Bx, By, and force in the member BC. But if we consider C, joint C, then there we have to find only CB and CY. And yeah, let's solve this and find. So select joint C. So okay, this is the reaction force. Let's say this is force in member BC, and this is force in member AC, which we calculated, and it come out to be minus 600. And just to be note that it is minus 600, so we reverse the direction of force. We reverse the direction of force and we got the force, it's towards the joint, right? So here also the force is towards the joint. So now in calculation I don't need to consider minus sign because I already reverse the direction. In case if you don't reverse the direction, only then you need to consider minus. So since I changed the direction, I actually can write as a plus 600 Newton. So here I already changed the direction. So if I sum the force in along x axis, then I will have, so again this is 4 7 root 65. So I will have so let me draw this coordinate also. So this is x, this is y. So I will have force in the member BC in the positive x and plus 7 by root 65 AC equals 0. So force in member BC will be minus 7 by root 65 AC, and AC was 600. So it will be minus 521.09 Newton. And since this is minus, again our assumed direction is incorrect. So it should be in away from the joint. So since it is away from the joint, it is a tensile force, and the magnitude is 521.09. So this is tensile, this is compressive, and this is also compressive. So any doubt until now? So if there is no doubt, then we can proceed to next question. So since we are solving too many problems of equilibrium, and now we are solving trusses problem which are based on the equilibrium method. So let you solve this question. Let me give you this problem to solve yourself. So try to solve the same problem by the method of joint, where you consider each joint, and at each joint you have to use the equilibrium equation on free body diagram, right? So just note that you have to use the equilibrium equation on the free body diagram. So you need to first draw the free body diagram at each joint. So use the same method that we have discussed. So until now we have solved two problems using method of joint. Then you can solve this problem by yourself, right? So again we come to our next problem, which we will be solving by method of joint only. The only difference is it is mathematically more involved. So until now, uh, whatever we did, we will do the same thing here. We will be selecting each joint, we will be drawing free body diagram at each joint, and then we will be using equilibrium equation, which is summation of force in x direction and summation of force in y direction. So we will be using so we will be using the equilibrium equation at each joint. So in this question also we will be doing the same thing whatever we are doing since last two question. The only thing is it is mathematically more involved, because you can see here it's so in order to find the component of force at each member, we actually required to find angles here. So these are the angles actually we required to find. We already given one angle which is 40, but we need to calculate the force at each member, and none of the members you can see is actually given in the orthogonal direction of x and y. So if I uh, imagine this is the coordinate system, then you can see none of the members is in the x or y direction, which means you have to take the component of each member. For that you need angles like this angle, then this angle, this angle. So before solving the question by method of joint, let's calculate the angle so that it is convenient for us to solve one for each joint. So it's the same problem that whatever we have did from last two question, it's the same thing we are going to do here also. But first we have to find the angle at each joint. Sorry, angle different angles we required to solve the problem at each joint. So if I consider this triangle, I have already given a side which is 5 meter, 12 meter and 13 meter. So I can find this angle. So I already know this is 90. This is also 90. So I can find this angle. So you have this triangle. This is 90. This is 13, 5 and 12. This is theta. So here if you use the trigonometry law, you will get theta is 22.619. So this is 22.619. Then what about this angle? So here you have to use the rule of triangles, which says that summation of all angles should be equal to 180. So if one angle is 90, here it is 90, and another angle is 22.619, so this is 22.619, then we have to find the third angle, which is this. Which is this here. So it will be x 180 minus y plus z. So it will be 180 minus 90 plus 22.619. So this will come out to be 67.38 degrees x. So this angle is 67.38. So now I can make another triangle here. So you can see, even though the concept remains the same, it's become mathematically or algebraically more involved, because here we need to find the angles, a different kind of angles. So if I found this angle, I can actually find this angle, because both of these angles should be equal to each other. Just imagine this system is rotating, right? So as this angle is changing, this angle is changing, this also changes equally. So if it is rotated to this one 90 degree, so it also become 90. So if this become 90 from the vertical, here it become 90. So you can see this also become 90. So this angle here is equivalent to this angle. So let's find this angle here. I mean angle DB, and let's say this is E. So let's find angle DBE. Let me draw in a more clear way. So this is my 22.619. This is 67.38, and now I am want to calculate this angle. Let's say this is E, right? So this is E, this is B, this is D. We already given this angle 40. We already calculated this angle, which is 22.619, and we want this. Let's say this is theta. We want to find theta. So you know that this angle is 90. So what will be this angle? So it is clear that it's 90 minus this we have to plus it. This have to make the sum. So it's 90 minus this angle, right? So it is 40 plus 22.619. So it's 90 minus 40 plus 22.69, and it will give you, I mean, if you solve this, it will give you 27.3. So this is 27.38. Then okay, so this is 27.38, and this is 90. Then you can find this angle also by using this rule, because here y is 27.38, z is 90, the another angle x, which is this x, you can find this angle also from this relation, and this x will be 62.6. So this is 62.6, and just the way we have found the angles here, we can find the angles here also. So if I consider triangle ABC, so this is actually one of the drawback of using method of joint, because sometimes when you use complicated truss, the method of joint become too long, or it is become mathematically too involved to calculate the forces in members when you use the method of joint. So this drawback can be removed when you use method of section. So that we will discuss next week. Method of section simplify the problem. So this is uh, and therefore it is easy to use method of section in the complicated truss problem. But method of joint is very easy to understand, because we already discussed about equilibrium concept, and we are using the same concept in method of joint. So we know that how to solve for each joint. The only drawback is it is little involved. It is actually too much hard work we need to do to find the forces, because here we already know, I mean, already we are calculating angles by so many trigonometric rule, triangle rule, and so on. But this is actually required when you use the method of joint. So if you consider triangle ABC, This is 90, and this we have to found. Then using same concept like we did here for triangle DBC, you will find this angle as 67.38, and this angle is 22.619, and this angle will be same as this one. So this angle will be same as this one, so it will be 27.38. So you can make another triangle here, right? So you know this angle, you know this angle also. So the remaining angle is just 90 minus 27.38 plus 22.619, like we did here. So it is like you have 90, and you know this angle, you know this angle, so it will be 90 minus this angle, 90 minus this angle. So it, when you do that, it will come out to be 40 here. This is 90, and this will become 50. So now we actually calculate almost all the angles. Now we can use method of joint. So let's consider joint A. Again, it's the same concept we are repeating that we have looked in previous two problems. Just we are trying to calculating the angles by various rules, and that's why you might seem that it is very difficult to solve, or it is pretty much involved in solving. But I just want to remind you the concept. If you know the concept, you will find difficulty in algebra only, but you will know the concept, so ultimately you can solve the difficult problems. You will just feel that you are working too much for the algebra, that is true, but since you know the concept, you can even solve more complicated and more difficult problem, because you know the concept, and that is the most important thing. So here we consider joint A, and our next step we already know that it's making free body diagram and using the equilibrium equation on free body diagram. So this is my joint A. Let's say this is my force AB. There is a vertical force due to the weight of this box, which is, and the mass is 900 kg, so weight will be 900 multiply 9.81. So this will be 900 multiply 9.81. Whole is the Newton. And let's say this is my force AC, and we already calculated these angles. So this is my angle which I calculated as 22.619, and this is the angle we calculated, which is 27.38. So now we can decide the coordinate system. So earlier we actually uh, assume the coordinate system, inclined coordinate system along this force, right? But because we want to simplify the calculation, but for here let me consider the usual coordinate system, because I want to show that nothing is permanent. It is actually based on our convenience only. So here I am choosing the this coordinate x and y, and we want to solve for the force AB and AC. So if I do the summation of force in x direction, this is my angle 40, this is 40, so it is minus AB cos 40, and for AC I can write it as minus AC. So you have multiple angles, right? In this figure itself you have 40, which is the angle of AB with the horizontal direction. You have an angle 22.619 and you have an angle 27.38. You can choose any angle to define the component. I am choosing 27.38. So when I do that, it will be sine 27.38 equals to 0. So you can also choose this. Let me magnify this image. Let me again draw. This is your AB, and this is, sorry, this is your AC. Sorry, let's say this is our AB, this is our AC. So as of now, I consider this angle, which is 27.38, right? Because if you draw the triangle here, it will come out to be sine 27.38, which is the x component. But you can also choose this angle, right? And it is 40, this is 22 roughly. If you choose this angle, it is 62, it will become angle 62. And you can see, then you have to use cos 62. So this can be written as cos 62 as well. Since you have multiple angle, you can write the equation in multiple manner. You just need to learn the concept, so you will not confuse yourself. Both will give the same result. So it will be AB cos 40 minus AC sin 27, because I have used this angle. You can also write in multiple ways. You just need to know the concept. That's all. So I need another equation because we have a two unknown. So the another equation will be the summation of force in y direction. And here for the AB, it's a negative in the negative direction, so it's minus AB sine 40, and then it's minus 900 multiplied by 9.81, because here this is the weight of the box, and minus AC cos 27.38 equals 0. If you choose this angle 62, this one 62, then it will be sine 6 uh, approx 62 instead of cos 73, and both are okay. It's your choice which angle you need to choose. So this is your equation 2, this is your equation 1. When you solve both equation together, you will get AB as 10.56 kilonewton and AC, which is minus 17.58 kilonewton. So for AC we have assumed the wrong direction. AC, the direction should be this. So it's towards the joint, so this is compressive force, and AB is away from the joint, so it's a tensile force. So now we know that AB is tensile. When we consider another joint, we can represent AB as a AB force towards the another joint. So now we consider joint C, this joint. We already calculated force in AB and AC, so we all calculated this and this. So this is my joint C. Let's say this is CD and this is CB. And this is CA. For CA, we got compressive force, that is towards the joint. So it should be like this. So this is my CA. So if I choose my coordinate system like this, x minus x, y minus y, and this angle is 27. We found 27.38, right? So this is 27, so this should be also 27. And this is 90. So we are splitting x axis here, so this will be 40 and above will be 50. So when I use summation of force in x, I will have minus CD cos 40. So CB is unknown, so it's minus CB cos 50, and we already know CA, which is 17.58, minus 17.58 sine 27.38 equals to 0. So this is equation 1. Then if I use the summation of force along the y, I will have CB, it is in positive y direction, so it is CB sine 50 minus CD. You can see the direction of CD is along minus y, so CD will be sine 40 minus CA cos, so CA is 17.58 cos 27.38 equals 0. So this is equation 2, and on solving this you will get CD, which is minus 16.23, and CB, which is 6.76. Both are in kilonewton. So for CD we need to correct the force, so it is in towards joint. So this is compressive, and you can see CB is away from the joint, so it is tensile force. So we found force here and this member also. Then we can consider joint B, because we have only one member left, which is this. So in AB, our force was tensile, which is away from the joint. AB was away from the joint. So if this is my joint, so this is my AB, and CB was tensile. Again, it was away from the joint. So this force is this CB, and there is a rope which is attached to B. So there will be a tensile force in the rope, which will be in the x direction. and for unknown force BD, this is the my unknown force. So I can assume the direction for this force. Let's say this is my assumed direction BD. This is 27.4 we found, and this is 50 we found. Right, so we can write down. So if I use the summation of force in the x direction, then I need to consider t. Since we the only unknown force here of interest, only unknown force of interest is BD, we already know AB, we know CB. So if I use the summation of force in the y direction, so we don't need to consider this tension force. So the equation can be written in terms of BD, AB and CB. So it will be AB cos 50 CB cos 50 minus BD cos 27.4 equals 0. So we know AB, we know CB. So AB is 10.56 cos 50 minus CB, which is 6.76 cos 50 minus BD cos 27.4 equals 0. So this will be BD cos 27.4 equals
Uh, these are vertical forces, right?
uh, no, we are taking the component of these are the vertical force. Yeah,
Okay.
sorry. So this is the summation of force in y direction.
CB cos, CB sin 50, no?
CB,
If it's vertical,
yes, yes, it should be sine 50. So this is cos AB, this is sine CB, and this will be,
cos.
yeah, this will be cos BD.
In the
So
equation, you've taken it as cos CB.
yeah, so this will be, yeah, this will be sine. Yeah, thanks. So this will be sine 50. So 0.76. This will yeah. So this will be 5.17, and this will be 1.601 divided by cos 27.4. So this will be uh, 1.818 kilonewton, and this will be positive. So which mean our assumed direction is correct and BD is away from the joint. So this is tensile force because it's away from the joint. So we now calculated the force in BD also. So just to repeat again, we have used the same concept. Each we consider different joint and follow the usual route. Just a little involved in calculation because we need to calculate angles, most of the angles here, and therefore it is uh, a very big method. I mean, very involved method. So this is the only drawback of method of joint. So to uh, tackle this drawback, next week we will be using the method of section, and you can see there is a huge reduction in the algebra of the problem. So there we don't need to calculate the member force in all the members, but we will see that whatever is the unknown force is required, we will be cutting down the members there. So for example, let's say in this truss we need to calculate the force in this member, then we will cut down this system along with this member, and when we draw the free body diagram we will be drawing free body diagram only on those member in which we make a cut. So we make a cut in member GH, DH and DC. So we will be making free body diagram here only. So once we make the free body diagram here, we can consider this part of the truss only, and then we can use equilibrium equation. So this time we will be using moment equation, summation of moment equation to calculate these unknown forces. And we can actually take this moment for this part only. We don't need to concern about this part, or if you want to consider this part then you have to remove this part. So it's your choice. So basically this is what method of section is. So when you choose the moment equation while solving by actually cutting the truss here across three members, you will see there is a huge reduction in the algebra. But since we are mostly familiar by the equilibrium method, you may feel that the method of joint is very simple to understand, but yes, it is very much involved also. So you can use method of joint in the simple truss like this problem we have solved, or you can use method of joint to solve this problem also. But in the complicated problem like this we have discussed, you see it requires a lot of algebra to get the force to solve for the forces in various members. So until today we actually use equilibrium method. So in the beginning of the class we use the method of equilibrium concept in a simpler rigid body cases. Then later part we use the same concept in the trusses. So next week we will be using method of section. So until then you can practice few problem on this PDF. So you can use method of joint to solve this problem. And in the previous week PDF I also uploaded that one in the drive. So you can actually solve last few questions by using equilibrium method. So this you can solve. So I actually didn't solve this one because I want this problem to be solved by you. So we solve until this problem. Here we use all three equation of equilibrium, and by using the similar concept you can solve this one also. So here also you need to determine the reaction like previous problems. For that you need to first analyze the joint, analyze the unknown reaction in the body force, free body diagram, and use the equilibrium equation.
Will you provide the answers at some point for those questions so that we can check if we have done correctly or not?
We can try in class. If let's say you have any doubt, then we can try in the class because I am also solving here only. I don't have any solution for all
For
of
those
this.
questions.
Yeah.
Okay, no problem. Also, just one more question. The latest problem you solved, right? The one with the string attached
Yes.
to the truss. So
Uh,
there is no way we could start with point D, right? Because of the number of unknowns. So that's not possible at all there.
mm, so the problem with point D is actually you need to consider reaction force also. So here,
Yes.
So yeah, it will make a problem even more complicated. So
No, we cannot start only, no, because the number of equations and the number of how do you
yeah,
say
yeah,
that?
yeah,
What?
because there will be three unknowns. So
Yes,
you cannot use two force equation to solve with D. Yeah.
three.
Because there
Okay.
is a reaction force also, right? So reaction force is also unknown. Then there will be dB and dc, which is another two unknowns.
Here, horizontal reaction force will not come in this scenario.
No, when you consider joint D, sorry, yeah, when you consider joint D, there will be no horizontal force. It will come only when you consider this joint.
It's a pin support, right? Usually there is a horizontal reaction
Oh,
to
sorry, oh, you mean at here? Yeah, yeah,
point
it
D.
will be.
Yeah,
Yeah, yeah, it will be. Yeah,
it
yeah,
will be there. So
yeah,
totally four unknowns, and we only
yeah,
have
yeah,
two,
four
three.
unknowns.
That's why we cannot
Yeah,
try
yeah,
from that
yes,
point.
yes, yes,
Okay.
yes.
Okay. Thank you.
Yeah. So okay, then we will meet next class.
Yeah. Himanshu, I have a couple of more general questions
Yeah,
about the course. Is it okay?
yeah, sure, sure.
Yeah, the first one is the book that is attached in the course. Someone has already put it in the question and answer section also. The page one and the index pages of this course, but the
Hmm.
rest of the thing is from a different course. It's unrelated completely. So the book is not for this course. So just the page one and the index is for this course, but the like 99% of the book is completely different, a
Hmm.
different course
Okay.
of some mathematics. So could you please tell someone to attach whatever the correct book is supposed to be attached there? That is one. And second is this particular course, right? So in the course description, it says Anubhav Roy is the professor, and then the first set of lectures are from Mahesh, Professor Mahesh, and then in the middle it's from a professor called Shivakumar, which are very old lectures. So is
Hmm.
this how the lectures are supposed to be? There is no mismatch there, right? It's correct
No,
in
it's
from.
correct. It's correct only.
Okay, so the timelines though are different, like the year it was uploaded, it doesn't matter, but it's
Hmm.
aligned properly.
Yeah. If you want, I can actually upload the mechanics book for the statics that I usually followed while.
Yeah, you can upload whatever is the appropriate book for this. Just
Yeah.
the book that is attached currently, it's not for this course. It's not for this course at all. Like, it's not related. It's just that
Okay.
sheet one and sheet two. I think someone had edited there for this course, but then the later part was not checked or it was not
Okay.
done.
Okay. Okay. I will check that. Yeah.
Thank you
Thank
much.
you.
Okay, also, last one more question. Sorry to
Yeah.
bother.
Yeah. Yeah. Yeah.
So this week one, week two assignments had a lot of velocity, acceleration, and equation of motion questions, but it's not there in the course syllabus. Week one, week two, they did not have that as a syllabus. So is it that we it's a prerequisite for the course that we need to know all those things properly, or will it
No.
be
No.
taught in dynamics or somewhere else?
I think it will be there in the dynamics. You will learn all these things in the dynamics if it is
Oh,
related to velocity only.
yeah, because the assignments for week one, week two is mostly that part. It's very less statics or something. Uh,
Okay. Okay. I
so
have to check the assignment actually. So let
okay,
me check the assignment and then come back to you that what are the question. I don't know actually what are the question are there in the assignment.
yeah, it's simple questions, but then again, it's not taught. So it's the only
Okay.
problem. I have.
Okay. Okay.
So in dynamics, they will start with those things, right?
Yeah. Yeah.
Acceleration.
Yeah. Yeah. Yeah.
It's
Yeah.
not the basics. Will it will be the
Yeah.
lectures.
So there are two parts in the dynamics. There is kinematics and kinetics. So in kinematics, you will be learn about only velocity and acceleration. You will not concern about the forces which cause these velocity and acceleration. So there you will learn that if you given velocity, then how to find acceleration. If you given acceleration, then how to find distance or velocity like that. But in kinetics, you have to bother about force. So there you have given force and you need to calculate velocity or vice versa, like that.
Okay, got it.
Yeah.
Thank you. Thank you much.